Okay, before the break, we're kind of setting some things up for a quick Ask C Sharp. Set up a little basic input output system on in a Unity game. So input, can't really see it here. There's an output box here, and a button to click on to make the processing happen. That way, we're not working in the console. Console's kind of boring. We're working in the console. We need to see the UI components for Unity at some point anyway. So we got that set up, and it runs a little hello world. And over the break, there was one person having an issue with spreading that out amongst multiple lines. Like, I quickly tried to change my plan from the example I have in front of me. I've got to stop doing that. Have an example that I know all works right in front of me, and I'll like try to change the plan. Be like, oh, maybe it would be better to do it this way. But splitting that up amongst several lines, still had an error message that had the word implicit. It couldn't be implicitly done. It has to be explicitly done. So splitting that up amongst multiple lines, having text output equals get component text goes an error. So it does need to go in this way. So that other thing I tried to change my mind to did not work. But when we click our button, we get this get the word showing up on the screen. But we want to do more than that. The reason we're doing this is to get a quick coverage of C#. And this is something you're going to want to often do when you're sitting down a program, maybe in language you haven't used before. It's kind of like put together your own little cheat sheet. A quick pass at all the basic functionality of the language to make sure you know what to do with that language, or have a quick reference to just a stripped down version so you can get that basic syntax going. But that's the first thing we need to do anytime we're going to program things. The hello world worked. So instead of hello world, let's start with just the basic math. That's our variables, math operations. We know we're going to do that at some point. Since we're in a game engine, we do want to use floating point data instead of double precision floating point numbers. It's a difference between 32-bit data or 64-bit data. You may have seen those in different languages. And the way game engines run, saving those 32 bits using the smaller data type will add up very, very quickly. 32 bits, 140 times a second for every single number you have in your game is going to add up to a lot of bits saved. And when you can save games, that relates to your machine's going to run faster. It's not going to get bogged down. I think most people are well aware of that, right? With games, it is still possible to bog down even the nicest computers made. We might ask for a lot to happen. And it really comes about because we do it 140 times a second. 140 times a second is usually the default anymore. So some computers would set that a lot quicker than some systems are set to a lot quicker than 140 times a second. But any place we can save that, it adds up. So instead of a double, that's the key word. Whoops. Let me try that without bumping my mouse pad. Double is double precision floating point number. That's what we usually use in business settings, because if we're talking about money, we don't want to lose a decimal point. Just because it's not up there in the two spots we write on a price tag doesn't mean we don't care about that money either. So we usually use that in business settings, but we want to use the one half that size. So our keyword is float. And I'll just give it an X, 3.14. And if we use, actually, let me throw the error here. If I save this and go over to the compiler, it's going to print out an error. It says a literal double cannot be converted to a float. Whenever we use the smaller data type, so the ones that aren't the normal go-to, we have to explicitly state it. So we also have like integers and longs, which are just a much bigger version of integer. You can hold a much bigger number. we have to explicitly state that we want a long, not an integer. And for floating point numbers, just add an F. So after you type your digits, throw in an F to say that is a floating point number, the 32 bits, not 64. And for a long, the integer equivalent, make sure you put an L. Usually, most people go with a capital L. It's not case sensitive for either the F or the L, but a lowercase L does look an awful lot like a 1 in most fonts. So that one's usually capitalized. Oh, I'll do another one so we can do some math with it. Float Y is 2.82. And I want a floating point number. Oh yeah, I guess I can hit save and show that the compiler, the error message from the compiler goes away now. Some warnings, but the yellow stuff, we can ignore the yellow stuff. We just need to worry about the red ones. Then most of the math is probably what you're expecting. If we add two floating point numbers, we get a floating point number back together. If we add two integers, we get an integer back together. So for this, we add them, it's going to be, we get back a floating point number. For most of our math operations, things are closed, right? We add or subtract or multiply two integers, we get back an integer. Two floating point numbers, we get back a floating point number. Division can be a little bit different, but we'll get to that in a second. Float the difference, x minus y, and it's closed under that operation. So our data type doesn't change. We don't subtract two floating point numbers and get an integer back. In certain situations, we could get 0.00000, but the computer's still going to record all those 0.00000. It's still floating point because we fed in two floating point numbers. Product the same, float. Product, I'll abbreviate it. X times Y, probably all the ones you were expecting here. Integer is a little bit different. We have floating point numbers, so if we divide floating point numbers, we're going to get back a floating point number. So I'll do division twice. Float 1 is x divided by y, and that's the calculator input you probably used to use it. Just 1 slash for the division. If we have integers, though, if we divide two integers, computers will keep that closed. They will go ahead and close the operation. So 3 divided by 4, y'all probably thinking 0.75, but we want an integer. If we feed into integers, we expect an integer back. So the decimal part gets truncated, and 3 divided by 4 is 0. So integer division, if you just feed in two integers, I'll write it like this or something. The integer quotient of, like, say, 7 divided by 4, using the same operation, we don't have a different one. And we'll put the remainder in there. If we're talking about integer division, then we also have the remainder, right? Which is 7 mod 4. The remainder when we take 7 and divide it by 4. Now we need to see these. I'm going to come up here at the beginning of the method, and I'll set output equal to an empty string. Do all this math, and then kind of print that out. So everybody's seen some Python. You see in Python, when we start calculating numbers in the string, you get a big problem, right? It never wants to do it. So, you got to cast that. Can I calculate int and string and all that? In any of our C family languages, it's fine. If we're in the C family, one of the methods that we should have implemented, it's almost a requirement, it's just like barely shy of being a hard requirement. And method we create in every single class that we design is a two-string method. What happens when we try to print it, when we try to turn it into a string? So it's basically, we can count on it being there in C family of languages. So to add it to a string, we can just put it right there. So output, I already reset that earlier. That's why I went up to the top. Started as an empty string, which actually I should do down here. Just printing that out. I'll reset it to an empty string and then just start concatenating on with the assignment operator. I often like to refer to those as reassignments, but by this point, everybody should have seen that in a different language. So plus equals is the same as output equals output plus something, or concatenation operation, but it's the standard concatenation, the plus sign. Oops. And then we can say something like sum plus whatever is in that variable sum that we found when we did the math, plus, well, then I'll do a new line. That'll work. I'll just do a new line to make it nice and organized. Output, concatenate reassignment. That should look familiar from, we do that in Python all the time, right? Or difference. And then concatenate to that word, whatever the difference we found was. It was called abbreviated, so it looks like it was just div. Plus a new line to make that look nice when we get to the, when it shows up on the screen. That way we're not printing just one long line, we have a bunch of line breaks. Oh, and end of instruction. Don't forget your end of instruction character. Most of your experience so far is in Python. You're probably going to forget that end of instruction, so go ahead and try to think that every time. Output, concatenate reassignment with the word difference, then concatenate on the actual difference we found, concatenate on the line break, end of instruction. Because we do have to explicitly type that end of instruction character. And I guess we'll do this for each one of these, right? Product plus that product we found, which I suppose is abbreviated, yeah. Plus another new line. End of instruction. Then we have the quotient. Quotient plus the quotient one we found. I guess an F would have made more sense there or something. Not floating point one, but we're just quickly looking at the syntax and now we're to the output of it. So plus equals integer quotient plus found plus new line in construction. And there's one more number we found. Output plus equals integer remainder. Because we can only have the split between quotient and remainder if we have integers. It doesn't make much sense to have a remainder with floating point numbers. Actually, the floating point part is the remainder. The remainder, yeah. Plus, don't really need a new line at the end, but I'll go ahead and do that for good measure and end of instruction. Most of that should look very familiar. It's almost identical to Python, except that we don't have to worry about casting. And that's consistent for all the Z family of languages. And then we still have that line of code that puts that string output onto the actual output interface, so we don't have to make any changes there. Save it, come back over here. The compiler doesn't have any error messages or warnings for us, so it should be good to run it. When we run it, every button, there we get all those numbers. I already forgot what numbers I typed in. Oh yeah, pi and e. So sum and e, sum difference, that looks about right for pi plus e. Only have 2 digits. They're not very far from each other. 3 point something, and a number slightly bigger than 3 and a number slightly smaller than 3 multiplied together should give us somewhere around 9. So that seems right, but you see that basic syntax we have there on those each time, and how the output works. And if you want to rush for time, like in a classroom, you might want to throw another input box on there and then make like a calculator, right? Enter 2 numbers and actually do that math, so you can check that. We're rushed for time, so let's just see how to use the input box so you would know how to do that. Like maybe during our lab time today, that might be a good little addition for lab time. That's the math. To keep this rolling along, I'm just gonna call it get out. Well, I'll do it right here. I'll just do it all in this one method. As always, it would be much better idea to split all this stuff up into a whole bunch of different methods. I can do it all in one place. Keep it easy here. Oh, and as far as we can. If we get to sliders and toggles, we'll have to do a different method there, but we'll see that in a little while. So for our input, I'll go ahead and reset that string. Input field. So I'll reset the string to an empty string. I'll just leave all that other stuff there. It'll be fine. We don't need to comment out or anything. The code's going to run, but we're not going to have so much code that we have to worry about extra stuff running. I'll just leave it there, and that way you can look at this as reference material later and comment and things. Well, we need to grab it from our other things. So I'm going to make a string, and the keywords public and private only go up at global scope. So earlier, notice I didn't have keywords private or public here, because anything created inside of that method only has scope across that method. So the method itself is publicly accessible, but we can't access anything inside of it. So our keywords, if we're inside of a method, we don't have to use the keywords. We just say we have a string, and this is our general C# syntax, the type of data we have, some sort of name for it. I'll call it input. And that is going to be just like we did on the output, only we don't have a way to ask for that text input box yet. But it'll be just like we did for the output. So I'm scroll up here, and I'm going to make another public game object. And I'll call it txt input. So everything's a game object. I could have called it an input field if I know what it is, but instead of stopping and thinking through what specific type of class it is, we can also just use game object every time. Because everything's a game object, and then public means there'll be a spot on our editor where we can fill that in when we get back over to Unity. And then we'll do the same thing. So that txt input, we can use, it's a game object. So as a game object, it has a get component method. And the get component, there's lots of them. I pointed at it earlier. It has a text component. One of the components in that input field was text. So we can do all of that. And then that text component also had a text data field in it, which, yeah, it's still on the screen. If you look a couple lines lower, See, we're doing basically the same thing. Only difference is which direction is our assignment going? Is our output or input field? The input, get the component, say what type of data it's gonna have. And then that, once the computer knows it's text data, then we can call that data field. Or that has the text we want. Then there's that, and then I'll put that in that output string. Output equals input. I guess I could have put it right there. I just wanted to add in the extra line. And then we'll set that on the output, and the output already puts it on the output thing. Oh, actually, we could probably put more. Let's add a bigger message. Here. So just kind of assuming a name in the input for right now. Like a name, get that input, and then bring that in as or a slightly more custom message than just saying hello world. I guess. And we keep having to wait for a compiler. If you used to Python, you're probably wondering about that. It's like, it seems like it's much quicker to do Python. You will actually wait longer in Python, but it happens between every line of instruction. So the interpreter runs one line at a time. So you're waiting the same amount of time because there's just so much time. It takes a certain amount of time to turn text into machine language. So the waiting's the same, but in an interpreted language, it's spread throughout. So the language is, anything you do with that language will be running slower because you have to wait once it runs. With a compiled language, it does all that beforehand before you can even hit the run button. Now, if I type my name in there and hit the button, should get some sort of message. Nope. Oh, I got to assign it. So if I come over to the game object, there's the field for it. Now, if I drag that input field over and do that assignment, try that again. Oh, maybe I have to stop. Notice when I stop, that it's no longer assigned. Did I assign the wrong thing to it? I drag that over there, hit run. I'll type in my name and click the button. Oh. Object reference not set to an instance of an object. Looks like it's line 42. So it should be assigned here. We come in here. I don't see what's different than what I did this morning. String input. I'm going to retype that line because I don't see where I'm missing anything. That string should be our text input. Or it was called txt input. Dot get component. It should have a text component. Dot text. And input field. Oh, well, there's a problem. over in the inspector, that output field, it had a component called text. Click on the input field, it doesn't have a text component. It has an input field component, and then that input field component has a text field. So our data type isn't going to be text, it's going to be input field. We do have to be very, very careful with the type of data we're using each time. And I apparently spelled component wrong. It component. Fix all the typos, and there we go. No error messages. That's usually a good sign. When it runs, type something in there, hit the button, and that's how we'll grab input from one of those fields. So you do want to be careful, like we saw there. Make sure you look at the objects over here and the type of data you're trying to grab does exist as a component. What's we have? These are some like basic inputs and outputs, things like that. And we're just going to copy that. I'm going to comment that section out. Because for our basic pass in C#, we solved that. Think back to your first programming class. What do you learn right after you learn variables and basic math? What's the next thing we do? We need to make some choices, right? Might have some alternatives so that we can do more than one, have more than one path through our program. So selection structure. So all these things should sound familiar compared to your other programming class. We're just going through it really, really quick here. I'm going to pick a couple numbers, and when I was getting ready this morning, I just randomly picked these three numbers. I'll say M, since we used X and Y earlier, I'll go somewhere in the middle of the alphabet. N is 4, and int K is 5. That's what I randomly picked earlier. Let me put another comment in here. 2 ampersands is and 2 pipe symbols is or. A single one bitwise. So bitwise is, it compares bit to bit, and is what you're probably used to using with the word. 2 things, if the first condition is true and the second condition is true, then we get 1 bit back that says overall it's true. Bitwise would go bit by bit. So if we feed in 8-bit integer and another 8-bit integer, we get back 8 bits, not just 1 bit. I have never encountered a use for it in the high-level language like software things. Use it all the time for IoT devices in embedded systems, when we're directly controlling the machine. It gets used constantly. But every single programming language has use for it. Maybe I've just never personally encountered it. In short, we want and with 2 ampersands or 2 pipe symbols. But if you're not used to that symbol, that's right above the enter key. The shift, the same key is backslash. And our syntax, well, we use the keyword if, that's fairly common. And then conditions are going to look very similar. So like if M is less than N and M is less than K, you say output will be assigned M is smaller. which once again should probably reset output. Output starts as an empty string, end of instruction. Then we'll do this. So if M is smaller than both of the other two, then M's the smallest value, end of instruction. The next one is a big jump from Python. In Python, white space matters a lot, right? I've already said that several times today. White space does not matter at all in the C family of languages. In Python, white space matters, so whenever we do our conditions, when we get to that middle one, the otherwise, else, if, we can't have two keywords in Python, so we get that gets abbreviated into elif, but here we'll actually spell it out as two words, else, if, and then our next condition, which I'm just going to check the same thing. If n is smaller than m and n is smaller than k, then we'll output n is the smallest number. End of instruction. And if it's neither one of those, then the final block is else. And you see how those curly braces are being used to block out the lines of instruction that go together. If you use to Python, those two words are the equivalent of the elif in Python, because we can't have a space in Python. You'll see else if spelled out more often than the way Python does it. And then another condition, ands and ors, it all has to be done with the symbols, and one set of parentheses has to be there. If you start nesting things, it's a good idea to put multiple parentheses, like it always is. But one set of parentheses, keyword if, and then stuff in parentheses, and then this curly braces blocking out the stuff that's going to run when that condition is true. Output, it looks like A is smaller. So a couple different outputs depending on which one of them is smallest. Right now N, so we should hit that else if condition, right? If you hadn't guessed immediately that I'm going to change those numbers, we'll make sure all three of them run. No error messages, so if we run it, hit the button, and N is the smallest number, which matches a desk check, right? We come over here and look and act like we're the CPU. It's like, okay, yeah, N is definitely the smallest. So that was the correct sentence. But if we change that up, let's make that 14, and this one 3. Now M should be the smallest. Give that a quick run and see what matched our expectation. The one we knew was smallest is what runs, but we're just looking at the syntax here. We already knew a computer could calculate that stuff. I'll switch that back to 13, so now K is the smallest, and just make sure that else block runs as well when it's expected to. Yeah, no real surprises there, but we're just doing a syntax pass. And see how we're starting to get like a little cheat sheet together. Nothing fancy going on here. It's just the most stripped down basic approach of C# syntax to get it started. Anytime you do a new language, you'll want to put something small like that together. What's next? Loops. Yeah. I'll do two types of, I'll do a while loop for just a basic loop, and then a for loop to go with a list. So I want to cover that all at once. But as always, our loops are generally interchangeable. The rule of thumb is going to be if you do not know ahead of time how often it'll loop through, then you want to use a while loop. A for loop should be used on an iterable or a countable. And countable does not mean we know the number. Countable means we know it does end. So a while loop would be like for a thermostat. Okay? We know it's going to happen when the temperature changes above or below 30 to 72. That our air conditioners are going to kick on or off. But we have no idea when that's going to happen. Okay? The absolute best humans can do is use the most powerful computers on earth to try to get a small, a reasonable probability that it's going to happen during a given day. Okay? There's a 10% chance that it's going to be warm enough for the air conditioner to kick on. That's the best we can do as far as knowing when the air conditioner is going to kick on. Compared to the actual measurement that I get 72 degrees, time to activate the machinery. That's when we would use a while loop. So again, I'll reset the output into instruction. I'll just do a counter, integer counter equals 0. Seems like a good place to start. And this is going to look a whole lot like Python if you consider the difference between Python and the if block we just looked at. While, and then we have to have parentheses. So keyword while, and then our condition goes into parentheses, and the while loop will run for as long as this is true. Oh no, counter is less than 8. Seems like a good number. Let's see, output reassignment with, well, I don't know, the number is growing. Number is growing. It's at plus whatever our counter is currently at. And then we'll do counter and, counter equals counter plus 1 is what we really want to happen. But that's one of our most common things to happen, right? Increment. Increment and decrement are probably the things that we do by far the most often. So there's an abbreviation for it. Actually, the abbreviation is written on the line above. It's equivalent to that. So that statement is equivalent to saying counter plus equals 1. But plus or minus 1 is even more common than any other number, right? So we have an extra abbreviation for this. For that special case when it's 1, we can say counter plus plus. Or counter minus minus. Or we can put the plus plus out front. There's a difference between pre and post increment. We'll just do the post increment because it starts to get confusing if we dive into the differences between pre and post right now. But I'll write it here. We can also say plus plus counter. And then it'll be, we're not doing anything else, so it'll be equivalent. But counter plus plus is for that special case where we increment by 1, or counter minus minus if we want to decrement by 1, because that number is going to be so much more common for our increment or decrement value than anything else. So it gets a special syntax. Then we have what output has, so I'll save that. Notice how similar it is to what a while loop looks like in Python. I know everybody's seen Python. It's just that C# syntax that's slightly different than the Python syntax. And when we run this and click the button, we should get that. I guess I probably could have put some line breaks in this one like we had earlier. But you'll also notice that word wrap is the default. By default, I forgot what line breaks, so I tried to print one line, but it looks like by default we have word wrap on, which I might as well point at that. On output field, over on text, you'll see somewhere over here is There it is. Horizontal overlap. How do we deal with the horizontal overlap? And it either wraps or overflows. Or vertical overflow. We can just let it overflow and keep writing, or we can just truncate it off when we hit the bottom, when we run out of room. That's where those options are. I probably should have put some line breaks in there. Counter plus line break. And that'll print it out a little bit nicer looking. So nothing too fancy there. We didn't get all the way to 8, right? We didn't have enough room for it. That's what that truncate is. So I go to the output field, and on these parameters, vertical overflow instead of truncate. Truncate means just cut off. When I overflow, now we should see the rest of those, yeah. Well, we completely ran out of room at the bottom of the screen. It couldn't overflow any further, but it overflowed as far as it could. Remember, our text box ended here at 5. So it added 6 and 7. Oh, wait, I guess 6 and 7 are there. Yeah, I said less than 8, so that didn't go all the way. Let me add a number to see if it keeps going. Let's say 11. That should be plenty past it. Because that's where it was. It lined up awful nicely with the bottom of the button. It made me think we hit the bottom at first, but it should have just kept going. Yeah, there we go. So it just keeps, overflow is just going to keep going until it runs out of, until there's no spot left on the screen. So for a for loop, you can go ahead and do a list for a for loop. Lists and for loop. We do have arrays in C#. It is the C family of languages. So we do have that. And the C family, we're in a strictly typed language. So we do have that definition of array that Python never quite meets, right? A collection of similarly typed data that have the same type stored via a recursive operator. So the computer sets up the whole array ahead of time, all the space we're going to use in RAM, every resource we'll have a need for it, which means it's much, much faster. But it's non-dynamic. If we forgot something and need to add it, right? We say we have 8 things in our array and then realize later we needed a ninth thing in there. We have to make a bigger array, copy everything over in order to get that extra one that's non-dynamic. So lists are a little bit easier to work with. Those are the ones that, instead of a recursive algorithm set up ahead of time, every piece of data that we store in it just has a pointer at the end pointing to the next item. So we can keep pointing to more items, or we can, if we want to remove something from the list, we can stop pointing at it. And it's a much more dynamic structure. That's what we have in Python, what everybody's used to working with. And lists are just generally easier to work with, but we would still typically say we had an array because list has preconceived notions in English. We use the word list all the time, and we do not mean the same thing that a computer list is. So I'll just show a list and skip over the array part, because then it'll be like what you're used to in Python. This is what you work with in Python. It's just we have to actually call it a list, because our type is that we have a list, but we're in a strictly typed language. So we can't just go and mix our data types. We have to say what type of data we want to put in this list, which should sound familiar when I was talking about the get component method. When they created the list 15 years ago, they had no idea what type of data we were going to store here. Not every type of data we had access to was even created then. So they had to use a generic placeholder. But now that we're actually putting our list together, we want to fill in that generic placeholder. So that's the angle brackets again. And then inside of those, we have to say what type of data we're going to put there. Let's make a list of ints. And if you've seen Java, we can put primitive types into generics. That's the biggest difference between Java and C# is that we are allowed to use generic primitives. So I guess it'll actually just a typo that we usually hit in Java because we forget we can't do that until the computer gives us a message. We can actually do it in C#. So we're going to make a list filled with a bunch of integers. Need a name for it. I'll call it numbers. And that is going to be assigned a new list, keyword new, and then a list. And over, again, we need that generic type. And then we need parentheses. It's not a method, it's actually a constructor on this side, which if all you've seen Python is, then all you've seen is the init constructor where we only have one possible constructor. And in most of our languages, we have lots and lots and lots of options on constructors. Python restricts it to only one constructor. So we're going to make a new one of these classes, give it this reference name so we can refer to it in our code. And this is the type of data it's holding, is what all those lines kind of mean together. Then we can add stuff to it. So I'll say numbers.add a 9, numbers.add 3, numbers.add 14, numbers.add. I'll put 2.7 just to show that we should get an error message from that one. So remember, there's an error message because we said we had integers, but that's definitely not an integer. So let's see what happens with it when we try to put a floating point number into it. And then a for loop. We have the keyword for, and then we need 3 parts, which are actually the same as what we used in our while loop. We need to set up a counter, or set up some sort of integer counter. Then we need a condition for how long we're going to loop, our true condition basically. And then we need to increment that counter so we don't run out. So actually we built a for loop here. We just need all of those parts in these parentheses. So there's an integer, usually we call it I, either for index or integer or whatever you want to think of. Or throw in a more useful term for the given situation. It's always good to put something meaningful for your variable names. And it's going to start at 0. Our indexing in the list starts at 0. Index 0 is the first item in the list. And as long as I is less than count, I think, numbers.count. We have this all the time. It's very, very similar in different languages. It's close enough to make it confusing. I'm pretty sure it's count in C#. If it's not, we'll come back and adjust it. Whoops. And then I++, because we want to increment by 1. We wanted to start at the size start. We could switch that 0 and numbers.count, right? Integer I starts at number.count. While I is bigger than 0, I minus x. Go the other way. Hopefully that all makes sense. And then I guess I'll just add them to that list. Output concatenates with numbers. Yeah, I'll use it this way. Whatever the ith index is, plus a comma. Then I'm gonna add a line break afterwards. And again, these are all strings. Double quotation marks and single quotation marks are not interchangeable. A single quotation mark is for a single character. A double quotation mark is for a collection of characters, which is a string of characters. I'll repeat that just to show different syntax. So let's make a list of strings as well. So on another list that has a bunch of string data in it, I'll call it names. New list. We made our string data and then some parentheses. See how that looks almost identical. The only difference is the reference name we're using, how we're going to give it our code, and the type of data we need. So I wanted to show that twice. Then we can just add some stuff. So like names.add Bob and names.add Sally. And these do not represent any people. I'm making these names up off the top of my common names made up off the top of my mind. Names.add Becky. And that's probably good. And then our for loop for int name equals 0. Name is less than names.count, I'm pretty sure. My other computer went to sleep, so I can't quite look at the list just yet, or look at the prepared example just yet. And then we'll just output that. So output, we'll add to it names, index name, plus a comma and a space, end of instruction. So that one with a more useful word in our for loop, right? It makes sense to have useful words there, but we're using it as an index. Maybe N would have been a good one in that case. N for name. And then our output still goes to the same output box. This one is not. Oh, whoops. The standard convention for C# is method names are written in methods are written in Pascal case. So over here, the error message said the line number 87 and 88, 89, 91. So it's on there a couple times. List does not contain a definition for add in quote marks, and no accessible extension method for add. So I haven't made a child of this to customize my own. And that's the naming convention. C#, most of the built-in stuff. Built-in methods are all with Pascal case, so we need a capital letter out front. Like always in programming language, it's case sensitive. That one is just because I've been typing Java lately, and Java does camel case for the methods. Those sort of things blend together, kind of like I couldn't remember if it was count. Count didn't show up on there, so it must be count in C#. It's linked in Java, or size, or what is it? It's LEN in Python. We use it to do something different all over the place. It's linked in JavaScript as well. That's the only thing Java and JavaScript seem to have in common. Is the list is .link to get the size of it. Sometimes it's .size. That one, it's very similar in all our languages, but just enough to blend together. And here we have that error message on line 79, cannot convert from double to int. So that's that strictly type one that I put in there, if you remember that I did that. We said we had a list of integers, but tried to add a floating point value in there. It's like, no, can't do that. So I'm just gonna take that one out of there. That was just put in there to show you what would happen if you tried to do that. plus plus cannot be applied. When did I apply it to this? Oh, name is our integer. And names is our list, and it looks like I included the S in the condition here. So name plus plus, not names plus plus. We can't increment a list. We can increment the index for the list. There we go. You can see we got that collection of data, which that's something you're often going to want in your scripts for games, because there's probably a bunch of NPCs and a bunch of background props, and a bunch of mobs, a bunch of enemies, and teammates, and you'll have collections of things. So it's a lot easier to deal with things as part of a collection. I usually use the example of a backpack. Get your stuff for class, and it's possible to carry it around in a big stack. I think most of y'all have, at least half of y'all have had me in a class, right? It's possible to carry it around in a stack all day and get your stuff around school that way. But it's a whole lot easier if you throw it all in a backpack and carry it as a collection of like school supplies. The same thing with our code. It's hard to see the advantage of it at an introduction level. So that's the analogy I usually use in class for anyone who hasn't been in a class where I've used that analogy. What else? So lists. So that's a lot of stuff that most of our logic right there, right? A whole lot quicker than your first programming class, probably your second programming class. It was stretched out, but we started that at 226 and it is 224, so 58 minutes to get all of the syntax for C#. That's the basic syntax for it. That's our most basic elements that the entire programming language is built up from. All those keywords, our selection structures, our loops, our variables. Then after that, you can start diving into the particular methods that are built and will be useful. Some of them, like the methods built into your strings, you can probably guess the names already if you've seen them in at least one language. And if you've seen them in 2 or more languages already, you probably have a really, really good guess at them. Then you start getting into the more detailed versions. I usually haven't wrote a file, writing a file here. Lots of ways to write a file. So I'm going to do a quick, what I think is probably the easiest one. Write a text file. Because we probably want to save some stuff in our games at some point, right? Which means saving stuff, we need to leave RAM, go over to storage, put it there in such a format that we can get it back in. So I'll reset output again for the next section here. I'll create a string. I'll call it for file. And here is a string to write to a text file. That'll work for us, but basically a sequential text file. So you might remember from some of your other classes. In a game situation, your character is going to have XYZ positions, all the transform data, XYZ, rotation, location, rotation, and scale. We'll have all that data. Put each one of those numbers onto an individual line, stick that in a text file, and then you can shut down the game. And when you start the game back, you get back to that same transform position. Take hit points, magic points, experience points, health, all of those variables, write each one to a text file. And then when you start the game, check that text file and read them back in the same order you wrote them in, sequential. And then you're starting back at that last save point instead of the end. But for the syntax, I'm just going to write that string to a file, and that'll be enough to see the syntax. So, yeah. Get all of your stuff, can calculate it up into a nice big string with line breaks, 1 data point per line. For a sequential file, that's the easiest way to organize it. Keeps it human readable, and every variable you store in that text file, that's going to be the starting point when you come back to your game. So when you start the game, just the first thing you want to do is read that file. So you probably want to have a default version that has all the initial starting positions, or 000, help 100, and all that. And then when the player gets to a save point, you override that with whatever their health value has become, whatever position they move to, whatever their experience points have been added up to, and whatever it would be for your particular game. Just put all the data into a string, concatenate together a string. You all know how to do that. And there's lots of ways to do it in C#, but the easiest one is file dot write all text. And then we need two parameters here. And this is also going to look very similar to Python. I also chose this one because it's going to look very similar to what y'all have seen. Two parameters, what file? I'll call it sample.txt. That sounds like a good name. And then what string do we want to write? What is all the text we want to write? So what file are we writing to, and what is all of this all text that we're trying to write? That's the easiest way to write a file. I'll go ahead and write it. Output equals. Anybody want to take a guess at what I chose as the easiest way to read a text file? Even though we've only seen the one method referring to how to write it. Is that method enough for you to take a guess at what the other direction would be?
Read all text.
Yep. File dot read all text. And here we only need one parameter. Which file do we want to read all the text from? And then and then it gets assigned somewhere. Read all text from sample.txt. Actually, I'm going to add something else plus. And in between there, no, I'll just leave it like this. So the only place we could get, so those words are going to show up on the screen, but the only place they could come from the file. The only assignment is coming directly from the file. And then those words that we wrote to the file should show up, and we'll see where it writes it. And as far as the Unity project, if we don't pass in an address, and if you know what machine you're on, you can do the absolute address, go all the way back up to the C drive or the root folder on Linux or Unix system. Linux, there's not really Unix systems anymore. Go back all the way back to the root folder and do the whole directory, or if we put just the file name with no path to it, where does that put it? Let's take a look at that. Uh-oh. The name file does not exist in the current context. Any guesses on what I forgot? It's something we forgot earlier. Yes. It's an import. So we'll come up here and using system with a capital S .io, the default system in and out as the file stuff. So using system.io, we have this really easy write all text and read all text methods, which some of y'all might recognize are static methods because we have to put file.write all text and file.read all text. We then create an instance of that class and make it an object and then use the object to access that method. We went right to the class itself. So it's a static method. Some of y'all might recognize that. For others, that's a preview of when we would use static stuff. So we run this and click our button. There's a string to write to a text file. Well, actually, we've already If it got there, we already read it from the text file. So the big question is, if we go over to this Unity project, where is that located at? So in Documents in Unity, and here's the project we're looking at. We go in this first one. Up right at the top level, there's a little text file there, sample.txt. I probably could have come up with a better name. But if you remember from just a moment ago, sample.txt was the file we created. So that will automatically create it and do all that stuff. And it puts it at the top level of your Unity project. So in some situations, you might want to /assets, go into assets folder and put it with the rest of your assets. That would be a much more logical place to put your storage stuff. But we're just looking at the syntax here. A very, very quick pass at it, right? So barely over an hour. And I'm calling that that's the need to know C# syntax. It's a nice little cheat sheet. We have all those reference things we can refer to. The math, concatenation, putting strings together, how we get things from input and output fields, and other GUIs will be very, very similar. Other things that we would put in the HUD would be very similar, but usually the HUD is just an output, right? We wouldn't have inputs. The HUD has like that green box or a number there. It says you're at 74% health, experience level 29, your hit points are 74, and we're just outputting the numbers that the player needs to know about. That's what we would normally do on the UI panel. And we have how to deal with selection structures. So variables, mathematics, selection structures, loops. We just looked at a list, but we do have arrays as well. Formal arrays. I just covered one to get started with. Most people work with lists because that dynamic structure makes it a whole lot easier. And it's not 1971 anymore. We don't have to treat RAM like the most precious commodity on earth. We have lots and lots and lots of RAM. And it'll be a while before we completely run through it. For loops, and then writing files. And that's all our basic tools, right? And we also saw the structure, the general structure for creating public classes. Everything has to be an object in C#. How do we import existing libraries? How do we inherit from already existing objects? Set up our global data fields. We can access them from any of our methods. The syntax for a method, and then all those basic components for the fundamental components our logic is always built up from. And C# is a huge language, so there's lots and lots of pre-built methods you can use, but that's a matter of digging through documentation and seeing which pre-built methods are there and will fill any particular need. But the big thing I wanted to show was this is something you want to do every time. Look at the language you're doing and build that most basic cheat sheet. And now this file it's one file, which I'm going to disregard. I'll just delete the project. I'm only going to save this file, and it's like a cheat sheet. I'll put it on GitHub right now before we wrap up. GitHub. So on our course GitHub, there it is. It's got my username, Francis-Chris5, SDEV 148-fall 2022, everything in lowercase letters, and been following that naming convention. I'm going to add that one file. I just had that folder open. I guess I should have left it open. C# syntax project. In the assets folder, there's this C# script. Bring that in. And now there's a nice little C# cheat sheet on that GitHub repository. Because as you learn more and more languages, they blend together. Keywords are very similar. And sometimes that similarity actually makes it harder to remember than easier. because they're very, very similar, but they're also slightly different. Like that add method I forgot just a few minutes ago. Because I've been teaching Java class this semester, and in Java, that exact same method is lowercase a. Those little differences actually make it more confusing. So typos happen a lot. But you're always going to want to put a quick cheat sheet together for the language you're working in. And when it's your own cheat sheet, instead of just remembering where one's at online, you've done it once. It's all your own in your own style. So it's going to flow out a lot better. And having put it together, there's probably some other memories there that could trigger and help make more sense of it. So you always want to do that. Put your own little cheat sheet together for a new language when you have to start working in one. You can see it doesn't take very long. Just those basic tools, and that will get you a good solid start on it. That was a lot of information in 1 hour, right? It was probably a good time to practice that one on GitHub so you can refer to it. Does anybody have any questions before we wrap up here? I see a couple heads shaking no in the class. Most people are staring intently at the computer. I assume there might be questions. As always, I'm going to be sitting here waiting for questions to come my way from now to 3:50. But for the rest of the semester, we'll be doing stuff in Unity, so that's the syntax of the language we'll be using. The big thing, if you've only worked in Python so far, is you're going to want to get some practice using those semicolons. Get used to where those are on the keyboard and typing those without looking, because they're going to show up in just about everything we do the rest of the semester now. Otherwise, I assume the silence means no immediate questions. If you have any, from now till our scheduled time at 4:50, I am just going to be sitting here waiting for questions to come my way. As always, text messages and Ivy Learn messages are the two things that make noise on my phone. So Ivy Learn started doing that thing again where there's like a delay. Like sometimes it's 30 minutes or so before the Ivy Learn message shows up on my phone. So I'll probably have it pulled up on a computer watching that. But otherwise, that's the quickest way to get a hold of me. If you have any questions, let me know. Otherwise, I will see you all on Wednesday, and then we will do some more game stuff directly. Collisions, so that we can bump into things and make stuff happen. Have coins to pick up or enemy characters to punch, something. Figure out what to do then. I'll see you on Wednesday.